Okay, we just want to go over a few examples of non-linear functions, meaning our graph is not a straight line. Possibly it changes at a not constant rate. It just depends on what type of function it is. And if it's non-linear, then it's definitely not of the form f of x equals mx plus b, meaning it's not linear symbolically as well. Two examples that we may not think about as functions because they're so nonlinear are monthly average temperature of Chicago, which changes quite a bit throughout the year, not constantly. This is an example where it's not at a constant rate. And the height of a child from 2 to 18. There may be portions of this child's life where he or she grows at a constant rate, but over the course of this year span, it's definitely not constant and therefore it is not linear. And so first we're going to start off just looking at what a linear function has. This is straight through the origin, but it's a straight line. And let's look at 4 different examples that are non-linear. Here's one, which is the function f of x equals x squared. It's nonlinear because as we get to the center of this function, our growth rate is less than our growth rate as we extend toward infinity. It's not constant. The next example, the square root of x, is nonlinear for many reasons, one of which is that it doesn't extend through all real numbers. We don't have any negative x values here. Example 3, x cubed does extend through all real numbers, but it's not a straight line because again, it is not a constant rate of change. And our last example, absolute value of x. Very similar to a linear function. The difference here is that the linear function actually continues in one straight line, but our absolute has this sharp turn in it. It's still 2 straight lines, but it's not 1, and therefore it's not a constant rate of change because right here our rate of change takes a sharp change to a sharp difference. And that's just 4 separate examples of non-linear functions, not a straight line.